Hello everyone and welcome to the Pencil Tutors channel. I'm Sarfina and today I'll be teaching the topic of linear motion graphs. This is Form 4 Physics Chapter 2.2. So without further ado, let's get started. In this topic, you will learn three different graphs. First off, we have a displacement time graph. A displacement time graph records the displacement at the y-axis against time at the x-axis. Let's look at some of the basic trends of a displacement time graph. First off, if the graph is plotted straight across just like number 1 here, this means that the object is at rest. If the graph is plotted increasing linearly like number 2 here, this means that the object is experiencing a uniform velocity. If the graph is plotted curved upwards, just like number 3 here, this means that the object undergoes an acceleration. An important thing to note about a displacement time graph is that if you calculate the gradient, this corresponds to the velocity of the object. So if you calculate the gradient for graph number 1 here, you will get 0, which means that the velocity of the object is equals to 0 and the object is at rest. Next, let's analyze a common displacement time graph. I've already divided the graphs into 5 sections and I will explain what each section means. At section A, the graph is plotted increasing linearly, which means that the object is moving towards the right or the positive direction at uniform velocity. At section B, the graph is plotted straight across, which means that the object is at rest during this section. At section C, the graph is plotted decreasing linearly all the way to point 0, which means at section C, the object is moving towards the negative direction all the way to initial point. And at section D, the graph is plotted straight across at point 0, which only means one thing. At section D, the object is stationary or resting at the initial point. At section E, the graph is plotted decreasing linearly below the x-axis, which means that the object is moving towards the negative direction past the initial point. There's a few things to know that could help you understand the displacement time graph. First off, you need to know that the 0 at a y-axis of a displacement time graph is the initial point. So, just like at section D here, since it is plotted straight across at point 0, this means that during this time, the object is at the initial point. In order to know the direction of motion of the object, just look at the trend value of y-axis. At section A, the value of y-axis is increasing, which means that the object is moving towards the positive direction. At section C, the y-axis value is decreasing, which means that the object is moving towards the negative direction. In order to help you understand this better, I will show you the motion that is represented by this graph. Let's say that the object here is this point, right here. For section A, the object moves towards the right, so this will be motion A. Then the object rests for a few seconds, and that will be motion B. And then the object moves all the way back to the initial point towards the negative direction, so that will be motion C. Then the object rests at the initial point, so that will be motion T. And then the object moves towards the negative direction past the initial point, so that will be motion E. Next, let's look at a velocity time graph. Velocity time graph records the velocity of an object at the y-axis against time at the x-axis. Let's look at some basic trends of a velocity time graph. If the graph is plotted straight across, just like number 1 here, this means that the object experiences a uniform velocity. So that would be 0 acceleration. If the graph is plotted increasing linearly, just like number 2 here, this means that the object undergoes a uniform acceleration. Next, if the graph is plotted decreasing linearly, just like number 3 here, this means that the object is undergoing a uniformly decreasing velocity. or you might say it as a uniform deceleration. There's a few important things to note about a velocity time graph. First off, if you calculate the gradient of the velocity time graph, you will get the acceleration of an object. To find displacement of an object or distance traveled, just calculate the area under the graph. Next, let's analyze a common velocity time graph. Just like before, I've already divided the graph into 5 sections and I will be explaining what each section means. At section A, the graph is plotted straight across, which means that the object is moving towards the positive direction or towards the right at uniform velocity. At section B, the graph is plotted increasing linearly, which means at section B, the object is moving still towards the right, but with uniform acceleration. At section C, the graph is plotted decreasing linearly all the way to point 0, which means that it is moving still towards the positive direction, however, the velocity is decreasing at section C. At section D here, the graph is plotted straight across at point 0, which means that the object is at rest. And at point E here, the graph is plotted decreasing linearly below the x-axis, which means that the object is moving towards the negative direction. However, the velocity of the object still increases. It is very difficult to understand a velocity time graph, so here's a few tips on how to understand this graph better. First off, you need to know that the values of the y-axis of a velocity time graph corresponds to the velocity. For example, if we look at section A here, the value of y-axis at section A is the same, which means at section A, the velocity is constant. To know the direction of motion, you must know this. If the graph is plotted above the x-axis, just like A, B, and C here, this means that the object is moving towards the positive direction. If the graph is plotted below the x-axis, just like at E here, this means that the object is moving towards the negative direction. At section E, the value of y-axis is negative, which indicates it is moving towards the negative direction. However, the velocity increases because as we go down the y-axis, the numbers keep on increasing from -1 to -2 to -3. Therefore, the velocity still increases despite its negative value. I would say the positive or negative value of y-axis does not affect the velocity, but rather it's the number at the y-axis that will indicate the velocity. Finally, we have the acceleration time graph. Acceleration time graph records the acceleration at y-axis against time at the x-axis. Let's look at some basic trends of an acceleration time graph. If the graph is plotted straight across at point 0 here, just like number 1, this means that the object has 0 acceleration. If the graph is plotted straight across at a non-zero value, just like number 2 here, this means that the object experiences a uniform acceleration. If the graph is plotted increasing linearly, just like number 3 here, this means that the object has an increasing acceleration. Now, let's answer a question together. The diagram shows a velocity against time graph of a toy car. The first question asks, what is the meaning of velocity? Velocity is the rate of change of displacement. And the keyword for the answer here is the word displacement. This will be the one that will give you the mark. The next question asks, based on diagram 1, tick the correct answer in the box provided. The first statement says the car moves with constant acceleration at PQ. And the second statement says the car moves with zero acceleration at PQ. Since this is a velocity against time graph, at PQ, the graph is plotted straight across. Therefore, which means at PQ, it is moving at uniform velocity. If an object is moving at uniform velocity, this only means that the object has no acceleration or zero acceleration. So the correct answer would be second statement. If the car is moving with constant acceleration, then the graph should be plotted increasing linearly, something like this. Next, the question asks us to calculate the distance traveled by the toy car. Since this is a velocity against time graph, to find the distance traveled, we must find the area under the graph. So from point O to P, area under the graph would be 4.0 meter. And from point P to Q, the area under the graph would be 8.0 meter. So the total distance traveled would be 4.0 meter plus 8.0 meter, which the answer would be 12.0 meter. Next question shows a velocity time graph of an object. And the question asks, which acceleration time graph represents the same motion as in diagram 4? First off, let's label some of the points in this velocity time graph. I'll put this as point O, point A, and point B. From point O to point A, the graph is plotted decreasing linearly, which means that the object undergoes uniformly decreasing velocity or uniform deceleration. From point A to point B is plotted straight across, which means at this point the object undergoes uniform velocity or zero acceleration. Now, if we were to draw an acceleration time graph based on what we have already analyzed up there, first off, at point O to A, it undergoes uniformly decreasing velocity or uniform deceleration, so the graph would be plotted here. Next, at section AB, it undergoes uniform velocity, so it has zero acceleration, so it should be plotted straight across at point 0 right here. So the graph that looks like the one that we have just drawn is D, and the answer is D. Thank you so much for watching the video. I will also be uploading another video on Inertia today, so make sure to watch that as well. Make sure to like this video and subscribe to our channel. Don't forget, we post videos every Monday, Wednesday, and Friday covering the subjects physics, mathematics, and biology. Thank you so much for watching, and I'll see you guys around.